Okay, sir.
Hello, assalamu alaikum, sir.
Walaikum salam. Yes, Basha. You were disconnected once.
Yeah, sir. That time, sir, I was speaking, but don't know why you're not hearing me.
So today's experiment is this one. Our today's experiment is related to thermal physics. In last year, you did some experiments on temperature, right? You had any
No,
theory?
sir.
Hello, sir.
Hello, Lamisa. You did not have any experiment last year?
No, sir.
So you had theory on temperature and thermometer. In
Yes,
half
sir.
yearly or final, you had any discussion on there?
Yes, sir.
Temperature, I think it's maybe half yearly, right? Half yearly exams you had temperature.
Yes, sir.
So what you learned in temperature? Can you remember?
Sir, the average body temperature of a person. Things like that.
Okay.
What is Kelvin and degree Celsius?
Okay. Did you learn anything? Conduction, convection, radiation?
Yes, sir.
Yes.
I
Okay.
forgot.
Same here.
Then you understood how the heat is lost in surrounding area, right?
Yes, sir.
Yes.
Yes,
Okay.
sir.
So we will have some idea here, and how we are getting 0 degrees Celsius.
No.
Do you have any idea how to calibrate one thermometer?
How to
Sorry.
read?
The calibrate means if the thermometer is not marked, you are not having
Oh,
any marking in the thermometer. You are given
no,
the
sir.
assignment to do the mark. Okay, to do the marking in the or is making the scale on the thermometer. That is called calibrating. So you know what is the boiling point of water?
100 degrees
Yes,
Celsius.
sir.
100 degrees Celsius?
100 degrees Celsius.
And freezing point of water?
0 degrees Celsius.
Minus 0 degrees Celsius.
Minus 0.
Not
Just
minus 0 degrees Celsius. 0.
0. Okay. Then what is the melting point of ice?
Sorry.
so 0 degrees Celsius.
Melting point
Sir,
of
I
ice.
didn't.
Yes, sir.
Melting
Melting
point of
point is
ice.
it's then 1
100
degree
degrees.
Celsius because freezing point is 0. So melting point and freezing point.
10 degrees Celsius.
Yeah, melting point of ice is 0 degrees Celsius, and freezing
Yes.
point of water is 0 degrees Celsius. When you are saying melting point, then you are using solid. You are saying melting point of ice. That means at 0 degrees
0 degrees Celsius.
Celsius, ice starts melting. Okay, it's turning to liquid, it's turning to water. And when you are saying freezing point, you are saying freezing point of water. You are not saying freezing point of
Liquid.
ice.
Right.
So the difference is only the representation, but the temperature is same. Both
Yes,
are
sir.
reverse process. One is melting, another one is freezing. And similar way, we have boiling, then we have reverse process, condensation, right? Now we will have little bit idea on that. That's why I just having review whatever idea you have before. Now, Lamisa, Hello, Lamisa.
Sir.
So, Lamisa, can you send one picture to our group that our class is started? Everyone join. Then,
Sir, I'm actually using the laptop and I haven't logged in Facebook through laptops.
I'll do that.
I can't
okay,
really.
then who can do you do it? No problem. Then
Yes, sir. I'll do
today
that.
I told that today Adrita Anmol did not join yet, right? Then Tazrila is not here. So Adrita, you read today's part.
From a student investigates.
Yes.
A student investigates the effect of insulation on the rate of cooling of hot water in a beaker. He pours
I can't
250
hear her.
centimeter cube of hot water into a beaker and places a thermometer in the water, as shown in figure 2.1. He waits for a short time. He then starts his stopwatch as he records the temperature theta of the hot water. This is at time t equal to 0. Figure 2.2 shows the thermometer at t equal to 0. A1. Read the thermometer and record the temperature theta.
Yeah. What is the temperature reading here?
Sir, this is
87.5.
How much, Adrita?
7.5.
88.
Close to 88, but 87.5.
So it is upper meniscus, right?
Yes, sir. The upper meniscus.
Yeah, we should
Yes,
take the
sir.
reading of upper meniscus. That's why it should be 88. So right here, everyone take the notes A1. The answer is 88. 88, and the unit should be what? What is the unit for temperature?
Degrees.
degree Celsius.
Degree Celsius.
K.
Okay.
Can
Kelvin,
I
degree
can
Celsius,
I really go back
anything.
so that I can read the question?
Yeah, normally we have the reading in degree Celsius. Okay, then if we need to change the temperature in SI, the standard
It will be K,
unit,
sir.
then we are
Kelvin.
converting to Kelvin. Huh?
Yes.
Normally we are writing in degree Celsius. We are having the,
So it will be degree Celsius.
yes, it will be degree Celsius. Okay. So you write
Sir,
here
can you please write it?
88 degrees Celsius.
Okay.
Okay.
Yes, sir.
Yes. Now continue the other part, Adrita.
A2. Explain why the student waits a short time before recording the temperature of the water at T equal to 0.
Why?
Can you please go back? I want to read the beginning of the question.
Again?
Yes, I want to read it. The beginning.
Mm-hmm.
So she wants to read the beginning of
Sir,
the
you have to scroll
paper.
up. Scroll up.
Yeah, scroll up.
A bit more. Thank you.
Sir, he waits for the thermometer to
Not
take the
measuring the
reading.
time. Yeah.
Yes.
Wait. Later
He
answer.
waits for the thermometer to absorb the heat.
Yes.
Like not at
Let
all.
me give
I don't
me,
know.
guys, let me try first, please.
Look, you have to be very careful during dealing with this question, because here is given he waits for a short time. That means he is not giving too much time. He is doing the experiment then and there. He is taking the record then and there. Why? He waits for a short time. That means he is not waiting for a long time. He is doing it quickly.
We're trying to see how much the water flows. Depends.
He is taking the record quickly. Why? Again, Advita?
And
Taking the
so that
record quickly so that there is
the
no change in
temperature
actually.
doesn't go low again.
Yeah, if he waits for a long time, what will happen? The temperature will lost in surrounding area, right? The heat will be lost in surrounding
yes,
area. Then you will not get accurate reading, isn't
Yeah.
it?
Yes, sir.
Do you
yes.
understand why?
Can
Yes,
you
sir.
repeat it? I didn't understand.
Yeah, I am repeating. I am repeating. Let me permit them. Mithila and Azwat was in waiting room. Yeah.
Yes, sir.
So it's because if he waits for long time, there will be heat loss in the surrounding. Then we will not get accurate temperature reading. Is it
That
clear?
is
Right,
why
sir.
she for short
Yes,
time.
sir.
So if you are taking the reading in short time, then you will get accurate reading, and there will be no heat lost in the surrounding. So write
So
it.
what will be the
So write this: to get accurate reading of temperature so that no heat lost in surrounding.
accurate? So then
To get accurate temperature reading so that no heat is lost
Lost in the surrounding.
in the surroundings. Is it clear, everyone? In your copy, you should write it. A2, the answer is this one. Are you
Okay, sir.
done? Are you done?
Yes, sir.
Yes.
Can you go next part?
Yes, sir.
Okay. Azwad and Mithila. Hello, Mithila and Azwad.
Yes, sir.
Thank you for joining.
Welcome, sir.
Now, Anmol. Anmol, you continue, huh? B.
Okay, sir. B. The student records the temperature of the water in the beaker after 3 minutes. He then pours 250 centimeter cube of hot water into an identical beaker that is insulated with cotton wool, as shown in figure 2.3. He repeats the procedure. These results are shown in the table. Sir,
Yeah.
number
Continue the
1.
question.
Complete the column headings in the table.
Yeah, there is.
Number 2. Add your value.
Yeah, number one,
Yes,
first
sir.
complete. First complete
Sir, one
number one.
request, sir. Sir,
Yes.
sir, one request. Sir,
Sure.
can you tell others to stop chat? Because of the chat, I can't see the screen.
Who is chatting? Can you
Or you
tell
can
me the
disable it.
names?
Taki
Sir,
and Aswad.
Taki Azwad.
Taki Azwad, why you are chatting?
Guys, you
You are
can
not,
chat personally.
you are not concentrating in class.
Or you can disable it.
Yeah, I disabled,
Please delete it
but
now.
they should be careful, right? Yeah, look, now they can't chat, right?
Right.
Yes.
Okay, now the first one, you first answer the complete the column headings in the table in figure 2.4. So do it. You got some blanks, right? 3 blanks.
Right.
Yes, sir.
So in those 3 place, what you will write? The units, right?
Yeah.
The units for time,
Yes.
temperature, again temperature. So here we are getting 0, then 180.
Sir, it will be second maybe. 0 second.
Yes, because the time is given here 3 minutes, and if you convert
Yeah.
to second, it is coming 180, right?
Yes, sir.
That's
That's why
why
Yes.
I told.
it should be second. So second you can write completely second or small s.
S, small s.
Don't write SEC, then it is wrong. Okay, that is not accepted. SEC. Either you
Sir,
write.
Taki says that he can't hear you.
You can hear me?
Yes, sir.
Yes, I can hear you, but Taki said in the chat
So
that he can't hear you.
so it's his problem. Tell him to solve his problem. Okay. Then second, second is done. Then temperature. The temperature is theta without insulation, with insulation. Both are degrees Celsius.
Sir, it will be 85, right?
Celsius. Degree
The
Celsius.
calculation.
Yeah, both are degrees Celsius. Here you will write only the unit. This one is
Units.
quantity. Yeah. This one is quantity.
Time second.
Yeah. Beside quantity, you should write only the unit. In column headings,
So
you
it will
should
be S.
write the quantity name and the units. Is it clear?
For
Yes, sir.
example,
Yes.
Now, you have second one. Second question. Can you read, Anmol?
sir, I didn't get that. The last thing you explained.
Yeah, I said here we have quantity. Physical quantity's name is time.
Yes.
And you have to write here the unit. Slash,
Okay.
then unit. Physical quantity's name, slash, then unit. Slash, then unit. Okay, here. It is degree Celsius and it is time second. Now it is
Okay.
clear?
Yes, sir.
Yeah, Anmol,
Sir,
continue.
with insulation is also degree Celsius, right?
Yeah, temperature is measured here in degree Celsius. That's why both are same.
Okay.
Okay, continue please. Anmol.
Sir, number 2.
Yes.
Okay, sir. Add your value of theta in A1 to the table in figure 2.4.
Yeah,
Okay,
2.4 you have to write. Here is one box left, right? The other boxes we have
Yes.
values. So without insulation, what was the reading for
85.
time
Sir,
0?
can you
88.
go?
Sir, 88. 88.
It
Without
was
insulation, 88.
88.
Sir, can you go up?
Yeah, we can go up. You
88.
joined late, that's why you did not get it. Here we got the reading, okay? 88 degrees Celsius.
88.
Yes, I got it.
Now you have to
And
write
so
it
with
here.
insulation we get 85.
Yeah. So here you have to write 88, right? Please write
Yes, sir.
the answer in your copy also. Then part 3. Continue. Anmol, continue part 3. Yeah, Anmol, continue part 3.
Yes, sir. Sir, going. State whether the insulation has any significant effect on the rate of cooling in the first 3 minutes. Justify your answer by reference to the results.
Yes. Yeah, you have to check the results. Then you can do the comment, right? Statement and justification. So from the table, you make the statement and justify it. You got the answer, Anmol? Who got
Sir,
the
I
answer?
didn't get the question.
You did not get the question. Okay. Here you got this reading without insulation. Without insulation, you
Yes,
got
sir.
this. 88, then
Degree
75.
Celsius.
88, then 75. At the beginning, it is 88. Then after 3 minutes, it is 75. Then for the same time, at the beginning, we are getting here 85. After 3 minutes, it is 75. That is with insulation. So you got some
Yes, sir.
information here, right? Numerical information. And on those
So, sir,
information,
there is an effect on the rate of cooling.
then they are asking you state whether the insulation has any significant effect on the rate of cooling in the first 3 minutes. You will give the statement and you will give the explanation.
Yes, sir. It has an significant effect because in the first
The
3
temperature
minutes,
decreased.
without insulation, it was 88 degrees Celsius, and after insulation, it was 85 degrees Celsius. So yes, there is an
So temperature decreases.
yes.
So any other idea?
No, sir.
Sir, I got the same idea.
Okay, look,
I think I'm going to
Adrita,
Sir,
you want
I
to
think
add
it does
anything?
not have any significance. I think
You
not have
you
significance, maybe.
you tell me that from here, what is the temperature change?
From where, sir?
It's 3 degrees
Without
Celsius.
Yeah, it was
3
88.
degree. 3
without
degree.
insulation.
3
Without
degrees.
insulation, it was 88. Then it is now
85.
75. 88 to 75,
75.
right?
Oh, okay.
Okay, don't
Yes.
mix up, huh? You focus here in the column, huh? Without insulation, you check it is the showing the temperature difference how much for 3 minutes. 88 minus 75. How much it is?
13.
It's
13.
13.
13. That is without insulation. The difference is 13 degrees Celsius, right?
Yes.
Yeah.
And with insulation, we did one thing, that we are not starting from 88 then. We are starting from 85. However,
Yeah, 10.
after
10 degrees Celsius.
after 3 minutes, we are getting here 75. That means you are getting here temperature difference 10 degrees Celsius, right?
Degree.
So this information you compare now. With insulation, what you got after 3 minutes, and without insulation, what you got after 3 minutes.
So there is a significant difference. The
Yes,
temperature
right?
is the
The
same at the
statement should
10.
be yes. Yes, there is effect. And what is the explanation?
Uh,
When we, without insulation,
with
we got 30
insulation,
degrees Celsius. The temperature got decreased. Then with insulation, we got 10 degrees Celsius.
Okay, so when it is without insulation, there is more heat loss, right?
right?
As
Yes.
there is more temperature difference, we can say there is more heat loss, and that should be actually right.
Right.
From our experience, everyday experience, we understand that if there is insulation, there will be less heat loss, and if there is no insulation, there will be more heat loss, isn't it?
Yeah.
And this experiment is showing us that proof. This results showing us that proof. So what can we write here in the justification? Organize your ideas, then you tell me.
In fact, can I write like this? With insulation, the rate of temperature decreases less.
Yeah.
So with insulation, there is less heat loss.
With
The rate of
insulation,
temperature decreases less.
there is less heat loss. That's why there is what?
Effect.
Less temperature fall, right?
Yeah.
Can we
Right.
say that? Less temperature fall, isn't it?
Yes.
And
Yes.
with insulation, we have 10 degrees Celsius, right? Difference.
Yes.
So with insulation, there is less heat loss. That's why there is less temperature fall. Can you
Yeah.
write this? Can you write, or I should
Sir, can
write?
you explain it again,
Sir, you
sir?
should write.
Okay. Don't worry. I'm keeping it here only. No problem. So I'm writing here, huh? This statement, what should be the statement? Can you tell me? Yes, there is.
There is a significant effect.
There is. Then we are making it shorter. Here we are writing
Statement should be short.
with with insulation, less temperature fall. Less temperature fall. Okay.
The less temperature fall. Sir,
Yeah. Yeah. Here we got with insulation 10 degrees Celsius temperature fall in 3 seconds, right?
Yeah.
Yeah, 3 minutes, in 3 minutes or 180 seconds. With insulation, less temperature fall the same time. You can write in the same time.
Yes, sir.
Is it clear now? All
Yes,
of
sir.
you. Any confusion, anyone?
No, sir.
Okay.
No, sir.
So you are taking the notes. Are you writing the notes?
Yes, sir.
Yes, thank you.
Sir, can you scroll it a little? Oh, okay.
Little what?
No, no, got it, sir. Got it.
Got it?
If you could scroll it down, that's all.
Yeah, I will do it. If you are not saying you are okay, then how can I go down? Yeah, continue. Who will do it? Today we got Afnan, right? Afnan. Afnan, you read this part. See.
Initially, the main cause of heat loss from the beaker is evaporation. Suggest how the student can reduce heat loss by evaporation.
Yeah.
Hello, can anyone hear me?
Yes.
Yes. We got. So can you see the diagram and tell us how can you reduce heat loss?
Sir, by putting uh, cotton
Evaporation. Where you will put the cotton?
in the, sir, outside of beaker.
Outside of beaker you will put. Then evaporation will be stopped. If you put
Sir, we will
outside,
above
It
the
will
surface
fade
of the
more.
water.
yeah,
Sir,
above the
Sir, can I
surface
see
of
the
the.
question again, sir?
You want to see the question? Okay,
Yes, sir.
okay, see the question. Yeah,
Thank you, sir.
yeah.
I already told the answer.
How the student can reduce heat loss by evaporation?
putting cotton above the water.
Putting
Above the surface of the water.
above the surface of the water. So you are putting
Yeah.
cotton,
Yes,
To
sir.
block
or
the rays
or
of the sun.
or you can put
Or
any other thing.
we just have to build a barrier or a cover or a
Yes,
shade.
yes. So can we say that we can put a lid over there with hole?
Yeah,
With hole. We can do it
with
Because
without hole.
hole.
With hole
because
it won't work, right?
because you are having one thermometer over here, right? So
Right.
how
Oh
will
yeah.
so
It will
how
be
will
the thermometer will go through the hole.
yeah, and there in in between the lid and thermometer where you are making the hole, there you can keep some cotton, right? Or
Right.
any tissue like things, soft things, so that you
So
can
the hole is
reduce.
for cotton.
Yeah. So here we are getting other part. Huh? So first part suggest how the student can reduce heat loss by evaporation. You will write here by putting one lid above the surface of what beaker, right? With a hole, with
With
a
the
hole
hole for the thermometer to pass
for the
through.
thermometer to pass through, right? Then in the second part, you got state one other modification to the apparatus in figure 2.2 that reduces further the loss of it. Then you add that one I told. You in between the lead and thermometer, you have some space. There might be some heat lost also, right? So that part you give some cotton, right, for insulation. Are you clear?
So the answer is by putting one lid with a hole above the surface of the beaker.
Yes, this
So
one, the
that's the
first.
first part.
That is
Sir,
first
for
part
the
and second.
second part,
Hmm.
by placing a lid over it with a hole for the thermometer to pass through,
Hmm.
then with a comma, block
Hmm.
the hole. After you place the thermometer through the hole, block the available empty space with some cotton. Okay, some
Yeah,
cotton.
Oh
Okay.
my
very,
god.
or any other insulation like tissues, right? Or
Right.
cotton, something like that. Okay,
Sir,
then
can you please
D.
write it?
Then part D. Continue, Afnan.
So from D or number 2?
D, D.
Number
Number
two,
two
we
is
did.
done. Number two we did. Yeah.
Step
D.
1. Okay, so step 1, quantity that is kept constant to make a fair comparison between the rate of cooling of the two beakers.
Yeah.
Degree Celsius.
Yeah. What you will keep constant?
I guess the degree Celsius.
The room temperature should be constant.
Yeah,
This
right,
is
right.
one
Yes.
thing. Then the volume of water should be constant. Another point, okay? If you are taking different
Sir,
volumes,
they
there
they
will be
said to mention
difference.
one.
Yes, only one, but there are many. From there, you will choose only one. Okay?
So then the volume of water or the
Should be
room
constant, or the
temperature.
room temperature should be constant. Okay? So this one is your homework. Okay? To finish it, you have to finish it by Saturday and submit me. Okay? I will upload in the Google Classroom.
And number 2 or the
Yes, sir.
whole worksheet?
This one only. Question number
Okay.
2 only. Okay. Allah Hafiz.
Okay, sir.
Okay.